Good morning, everyone. We are from group number 8, and I am Freshly Karacha. My other group mates, Joyce De La Serna, Joseph Francis Kalinawan, Missy Plantar, and Aubrey Rose Fajardo are all here to discuss to you all about concrete pavement. So, Portland cement is a combination of limestone, marl, or other calcareous materials and clay, shale, or like argillaceous substances. Portland cement is the most common type of cement in general use around the world as a basic ingredient of concrete, mortar, stucco, and non-specialty grout. It was developed from other types of hydraulic lime in England in the early 19th century by Joseph Asdin and is usually made from limestone. So we have here the different types of Portland cement. So the first type, or type 1 or 1A, or air entraining, this type of cement is for general concrete construction when the specified properties of the other four types are not required. So in other words, type 1 cement is not suitable for uses where the concrete can face chemical attacks or excessive temperature during curing. It can be used in applications like precast concrete products, reinforced buildings, floors, bridges, reservoirs, tanks, culverts, sewers, pavements, sidewalks, pipes, and etc. So type 2 or 2A, or air entraining, this type is for general concrete construction exposed to moderate action or where moderate heat of hydration is required. Type 2 has the same uses as type 1, along with moderate resistance to sulfates. It generates only a moderate heat of hydration and at a lesser rate. It is ideal for applications where the concrete comes into contact with soils or groundwater, having some amount of sulfate ions, though not excessively high. Its low concentration of C3A, which is lesser than 8%, imparts this resistance to sulfate attack. Type 3 or 3A, air entraining. This type is for high-strength concrete. This type 3 cement is chemically almost identical to type 1, though it has lesser curing time, which means it hardens faster. It also ground finer and contains a higher amount of C3S, both of promote the rapid setting of concrete. This type imparts strength faster than type 1, typically in less than a week time, though its final 28-day strength may be equal if not lesser. It is ideal for applications which require quick setting so that structures can become operational faster and where formwork needs to be removed and reused. It is also ideal for cold areas where the quick curing of concrete prevents damage due to frost. So, type 4 is for low heat of hydration. This type of Portland cement is designed to reduce the heat released during hydration. This is achieved by reducing the percentage of C3A in the cement. However, this type has a lower final and initial strength as compared to type 1. It is suited for the construction of massive structures with a low surface-to-volume ratio, like gravity dams, where a large heat of hydration may result in dangerous cracks. This type of cement is not commonly manufactured or available for sale, and is almost supplied for book orders. So last but not the least is the type 5 for high sulfate resistance. This is almost similar to type 2 except that it is even more tolerant to the attack of sulfate ions. This is achieved by reducing the C3A percentage even lower to 5%. So, it is suitable for buried concrete structures where the soil or groundwater is rich in sulfate ions. However, it gains strength at a slow rate as compared to type 1 or OPC. Like type 2, it is more common in the western United States and Canada. It is used for applications like canal linings, retaining walls, and culverts, which may be exposed to a sulfate attack. So type 1A, 2A, and 3A. These types are almost identical to the basic 1, 2, and 3 types, respectively, except that they contain small amounts of air entrainment admixtures which are blended with the cement during its manufacture. These mixtures form small air bubbles inside the concrete block when it sets, which is ideal for cold temperatures where freeze-thaw cycles can produce cracks in the concrete. The smaller water-cement ratio also increases the workability of the cement. So generally, Portland cement constitute the following chemicals. The first one is the tricalcium silicate or C3S. Tricalcium silicate or Ca3SiO5 or C3S is the main phase of Portland cement clinker. It is called a light in clinker because it is not pure tricalcium silicate and contains a number of impurities substituted in its crystal lattice. So the second one is the dicalcium silicate or C2S. The dicalcium silicate is less reactive than the tricalcium silicate. The third one is the tricalcium aluminate or C3A. Is the most basic of the calcium aluminates. It does not occur in nature, but it is an important mineral phase in Portland cement. The last but not the least is the tetracalcium aluminiferrite or C4AF. Is a dark brown crystalline phase commonly found in cements. In the cement industry, it is termed tetracalcium aluminiferrite or ferrite. So we have here the table composition and strength characteristics of various types of Portland cement. So the first column contains the types of cement, the second column contains the compound percent, and the last column is the compound strength normal Portland cement concrete percent. So concrete pavement characteristics and behavior. The behavior of concrete pavement that is exposed to loading and environmental effect entirely depends upon the quality of concrete, the underlying subgrade, and the base course. Generally, concrete is strong in resisting compression load acting on it, but considerably weak in resisting tensile stresses. Thus, concrete pavement acting as a beam resting on a weak subgrade and base courses is also weak in carrying heavy load associated with impact forces. The reaction and movement of the subgrade supporting the slab affects the stability of the concrete pavement. Concrete pavement design assumes the following considerations. First, that the pavement slab was designed as plain concrete beams. Second, that the transverse cracks on the concrete pavement cannot be avoided. The designer, however, presumes that the pavement cracks could be controlled by providing reinforcements to the slab joints with the following assumptions. Third, that the longitudinal cracks on the pavement slab more than 1 lane wide is inevitable. Fourth, pavement slab is supported by foundation that deflects when loaded but recover when the load is removed, assuming that the foundation materials are elastic or a dense liquid. So, definition of terms. Deterioration. Deterioration of concrete pavement is due to stress brought by load, moisture, and temperature. The stress of concrete is generally grouped into the following categories: A. Distortion, B. Cracking, and C. Disintegration. Faulting. For faulting to occur, there must be free water on top of the base course and pavement deflection across the joint due to heavy axial loads. Faulting is the result of pumping tremendous force or load that develop under pavement. So, there are two causes of faulting, which are loss of slab support and erosion of subbase. So, cracking. Cracking can take many forms in concrete pavement that could be the result from applied load, temperature, or moisture changes. The most common type of cracks are corner cracks, which is associated with excessive corner deflection, and transverse cracks associated with mixture or temperature stresses or poor construction methods. This integration appears in the form of durability cracking, scaling or spalling as the result of mixed design or construction-related problems like A. Durability cracking results from freeze-thaw action. B. Scaling, a network of shallow fine hairline cracks which extend through the upper surface of the concrete. This is the result from deicing salts, improper construction, freeze-thaw cycle, or steel reinforcement too close to the surface. Spalling. It is the breaking or chipping of the joint edges. It is the result from excessive stresses at joint, weak concrete, poorly designed or constructed joints. Control of cracks. Load transfer and joint alignment is sometimes dependent solely on aggregate interlocking. If the joint opening is considerably small from 0.03 to 0.04 inch, the projecting aggregate is considered tightly keyed, and when the edge of one slab deflects due to load, the adjoining edge will also be forced down. If the coarse aggregates are weak, as when the joints open so wide, the aggregate interlock is considered ineffective as means of load transfer. Although some agencies employed designs based on aggregate interlock, others adopted the use of steel dowels as load transfer devices at the pavement joints. Dowels can be painted, greased, or coated with asphalt for almost one-half of their length to break the bond with concrete, allowing the dowels to slip within one of the abutting slab ends. Skewed transverse construction joint in plain concrete pavement is being adopted. Joints are slanted 60 cm in each, 3.60 meters lands from the normal position. The offset places the inside of a double tire of a truck just forward of the joint, and at the same time, the outside wheels are just behind the joint. Transverse expansion joints. Expansion joints provide space allowance for the lengthening of slab due to expansion. Because of the many buckling upward of concrete pavement, engineers have come up with a conclusion that this blow-up serves as conclusive evidence that expansion joint is necessary. A concrete expansion joint or control joint is a gap between two concrete slabs. It allows the concrete to move when it expands and contracts due to temperature changes. Control joints create a break between concrete slabs and the other rigid parts of a structure. They allow movement without causing stress, which helps prevent cracking. Since year 1940, the provision for expansion joint at interval of 30 meters or less was almost universally practiced in load building. The reason for providing expansion joint is to prevent blow-ups by relieving direct compressive stresses before reaching the stage of unmanageable level. Based on the studies of more than 5,000 blow-up samples, it was found out that blow-ups occurred mostly in mid-afternoon at a temperature above 90 Fahrenheit during a period preceded by varying amount of precipitations. Longitudinal joints. Longitudinal joints are provided between adjacent traffic lanes. It is considered as hinges to provide edge support but allows rotation between the slabs. By this joint, flexural stresses that might cause irregular cracks along the length of the road are relieved or neutralized. Longitudinal joints cannot be considered as a major problem under the following assumptions. First, that there is no big load transfer across it. Second, the expansion and contraction movement developed across the pavement width is very small. Third, when lanes are constructed at different time using side forms, the joints are provided with key way in the first slab to accept load transfer. Fourth, for longitudinal joint, deformed tie bars are used because the purpose is to hold the slabs tightly together rather to allow the joints to open and close. Fifth, the diameter and spacing of tie bars are based on the force needed to pull the narrow pavement slab over the subgrade to the joint. Last, the length of the tie bar is determined from the embedment inside the concrete necessary to develop the strength of the bar.
To continue the report of Ms. Coracha, I'm Joseph Francis O. Kalinawan who will be reporting construction joint, reinforcement joint, the subgrade and subbase for concrete pavement, concrete proportion, and concrete mixture. Construction joint. The construction joint in concrete used to prevent any crack during its life period. Concrete has the property of expansion and contraction due to temperature changes, which is resulting in a change in the volume of concrete. If concrete pouring will be interrupted for quite some time, that cold joint will be inevitable. The practice is to provide a transverse construction joint. Deformed tie bars are used to hold the joint tightly close together. Construction joint is essential if the size or length of concrete members exceeds some specified time or limit. Construction joint or cracks should be cleaned and sealed to prevent infiltration of water to the subgrade and to keep dirt out of the joints. Materials for such purpose includes harder paving and air-blown asphalt, sometimes mixed with mineral filler, rubber asphalt, and the various rubber compounds. They are poured hot and stiff, then cooled. Others are placed cooled. They are some preformed scalant made of strips of extruded neoprene comprised for insertion into the groove joints. The sealant will expand and fill the space completely. Reinforcement of joints. Steel reinforcement for concrete pavement joints are specified in the design to prevent the widening of cracks produced by shrinkage or thermal contraction. The reinforcement holds the fractured faces in rigid contact, preserving the aggregate interlock and the intrusion of dirt or water. These reinforcing bars, however, is not intended to resist flexural stress being produced by loads or curling. The reinforcing steel bars are mounted in one layer along the mid-dip of the slab. Welded wire fabrics are also used as reinforcement for concrete pavement. The subgrade and subbase for concrete pavement. The construction standard for subgrade and embankment are precise and almost typical for all pavement types. Under the concrete pavement literature, the undercourse of selected material is always imposed upon between the subgrade or embankment and the concrete slab. The AASHTO interim guides recommend that the subbase must be extended from 30 to 60 cm outside the pavement edge to serve as an edge support for the heaviest traveled facilities. A treated cement asphalt subbase is recommended because it increases the fatigue life and reduces joint failure. The wide acceptance of stabilizing the subbase with Portland cement concrete pavement is due to the investigation result of pumping of concrete slab. Pumping is the ejection of water and subgrade soil through the joints and cracks along the edges of the concrete pavement. A repeated depression of pavement joints by heavy axle load is the activating factor in pumping. With the presence of water on the subgrade and churning it with the soil activates the fluid forming slurry that expelled to the surface. A continued pumping by heavy axle load will flush the soil from beneath the pavement to the effective location. Failure of the joints will be noticed followed by transverse cracking or breaking of corners. One crack will invite more chances for pumping action joint failures, and by cracking that will be progressive. Pumping is minimal where the subgrade have been constructed resistant to erosion by cement or bituminous treatment, or when the pavement slab is underlain by properly graded granular materials. Despite the continued studies, researcher and experimental development made, there is no assurance for an effective means of excluding free water from the under pavement joints, crack, and edges. So far, the use of undercourses with drainage provision is being considered as the solution to prevent pumping. Concrete proportion. The fundamental rule to obtain good concrete is the proper selection of cement aggregate on water does. First, type 1 or 2 cement is specified for concrete pavement. Number 2, water for concrete must be clean, free from acids, alkali, and oil. Water that is suited for drinking purposes is acceptable for mixing cement except water containing large amount of sulfate. 3. If concrete is to be strong, sound, and durable, the aggregate must have similar properties. 4. The mineral aggregate of concrete is about 75% of the volume or about 80% of the weight of normal pavement. And lastly, the maximum size of coarse aggregate is 2 inches. However, the use of larger aggregates according to some experienced highway engineers increases its length and durability. This percept is supported by reason that with larger aggregate, less water is needed, thereby increasing the ratio of cement to water. Under the cement-water ratio principle, concrete is stronger when water content is less. Admixture is a substance added in mixing that change the characteristic of concrete mixture. There are varieties of admixture available like the air entraining admixture, which is very common. Others like water, reducer, retarder, accelerator, pozzolan, and plasticizer are also used. Air entrainment is the entrapment of air in the concrete mixture in the form of evenly distributed small bubbles. It is used to increase the concrete resistance to surface scalings caused by teasing with calcium or sodium chloride. Another working advantage of air entrainment is improving its workability and reduces bleeding in fresh concrete. The effectiveness of air entrainment is to increase the concrete durability that is influenced by, first is the percentage of air present in the mixture, second is grading of aggregates, third is size and distribution of air bubbles. Air entrainment in concrete may be attained by using air entraining Portland cement or by air entraining admixture added to each batch or concrete while mixing. Cement and water ratio. As mentioned earlier, the strength and other desirable properties of concrete mixture varies depending upon the ratio of concretes to mixing water. A non-air-trained concrete with a water-cement ratio by weight of 5 gallons of water per bag of cement may have compressive strength of about 5,300 psi in 28 days. On the other hand, a mixture of concrete with 7 gallons of water per bag of cement has developed strength of 3,700 psi only for 28 days. Durability therefore is dependent on the water-cement ratio that should be properly controlled to obtain richness of the paste. AASHTO guide specification for highway construction established the maximum water-cement ratio at 6 gallons per bag of cement on normal condition and 5.5 gallons per bag of cement for severe atmospheric condition. Concrete mixture. Considering the high cost of cement, the objective in mixing concrete is to use more aggregates and as little cement as possible, while maintaining the workability necessary for a successful pouring and consolidation. For structural concrete poured in accessible small areas around reinforcing bars, it is necessary to overfill the voids or spaces around the aggregate and reinforcement using a free-flowing cement in water paste form. On the contrary, pavement where the slab is open and thin with an access to manipulate from the surface, a drier mixture can be poured inside the form with ease and success. Thus, a higher percentage of aggregate and less fluid cement water paste can be used. On how to reduce the amount of cement water paste and the cost of mixture, we have to first allow the larger size of aggregates that can be accommodated in the pavement slab. Second, ascertain the aggregate is uniformly graded from coarse to fine. Third is avail of the biggest quantity of coarse aggregate consistent with proper workability. And lastly, adapt the lowest lump consistent with the proper pour and finishing. For concrete pavement, the specified value of slump is 1 to 2 or 2 to 3 inches. The slump test is the old traditional and most widely used method in determining the consistency of concrete. A truncated cone of metal sheet 12 inches high with the base and the top diameters 8 inches and 4 inches respectively is filled in 3 layers with fresh concrete. Each layer is rounded 25 times. Then the cone is lifted off vertically allowing the concrete to subside. The slump is the height in the inches that the top of the specimen falls. Another way of testing the consistency of concrete is by the Kelly ball method. The apparatus is a metal cylinder 15 centimeters diameter and 12 centimeter high with hemisphere button shape weighing 14 grams. A graduated handle rising from the top of ball passes through a metal frame that is 30 centimeter apart. The ball is placed on the surface of the fresh concrete. Its penetration is measured by comparing its position with that of the frame. The advantage of Kelly ball method is that reading could be taken immediately on the concrete being poured on the roadway. On the contrary, the slump test requires more time but could be conducted only on selected samples. Concrete mixture is determined by the trial batch method until after the desired mixture is obtained as final proportion for the succeeding mixture.
Good morning, everyone. My name is Joyce N. De La Serna, and I'm about to continue the report. So, polymer concrete. Polymer concrete could be used alone or in combination with Portland cement to bind aggregates together preceding concrete. So, polymer concrete is a composite material made by fully replacing the cement hydrate binders of conventional cement concrete with polymer binders. So, polymer mixture is classified into the following: polymer impregnated concrete PIC. Number two is polymer concrete or PC. Number three is polymer cement concrete or PCC. So polymer impregnated concrete is a Portland cement concrete impregnated with monomer after curing. Polymer concrete. So it is a mixture of a polymer binder and aggregates. And lastly is polymer cement concrete is a premixture of cement paste and aggregate wherein the monomer is mixed before curing. So, polymer concrete can be used for new constructions or repairing of old concrete. Polymer possesses a higher strength concrete, but due to its prohibitive cost, its use is being limited to bridge, deck, or repair of spalled joints. So, polymer concrete has advantages of higher properties, which is low energy requirements and low labor cost. So, it is a high durability and resistance to weathering conditions. Curing of concrete pavement. Newly placed concrete pavements needs curing. Curing may be accomplished by several methods, but basically all the methods could be categorized into two. So number one is those that keep the surface constantly wet or cover it with water absorbent material that is re-wetted from time to time. So number two is those that pavement evaporated from the water already in the concrete which is retained is sufficient enough for hydrations. So curing is a treatment or protections of concrete during its hardening period. It is providing adequate moistures, temperatures, and time to time allow the concrete to achieve the desired properties for its intended use. So how many days is curing of concrete? So concrete is typically takes 24 to 48 hours to dry enough for you to walk or drive on it. However, concrete drying is continuous and fluid event and usually reach its full effective strength after about 28 days. Elements of roads and highways. Strength of concrete. If the concrete dries out quickly, hydration and strength process will stop, but when the moisture becomes available during hydration, strength gain will continue. So rapid during of fresh concrete will result to surface crazing or cracking under extreme hot weather or dry winds. Severe cracking will eventually occur. The shortest period of curing for normal concrete is 5 days according to ASHTO recommendation. DPWH Specifications of Concrete Pavements. Concrete pavement is categorized under 311 of DPWI standards specifications. Materials requirements. Portland cement shall conform to the applicable requirements of item of 0 to 700 hydraulic cement. Only if only the Portland cement should be used. Cement that for any reasons become partially hardened or which contains lumps or cake cement, including those salvaged from discarded or used bags, should not be used. So fine aggregates. Fine aggregates shall consist of natural sandstone, screening or other insert materials with similar characteristics or combination thereof having hard, strong, and durable particles. Concrete pavement should it has it shall be free from injurious amount of organic impurities. Fine aggregates from different sources of supply should not be mixed or stored in the same pile nor used alternately. Fine aggregates should not contain more than 3 mass percent of material passing the 0.075 millimeters number 200 sieves. The use of beach sand will not be allowed without the approval of the supervising engineer. And if the fine aggregates is subjected to 5 cycles or the sodium sulfate soundness test, the weigh loss should not exceed 10 mass percent. And lastly, if the aggregate is subjected to the test for organic impurities and a color darker than the standard is produced, it should be rejected. And this is the table grading requirements for fine aggregates. Coarse aggregate. Coarse aggregate, it shall consist of crushed stones, gravel, and blast furnace, slag, or other approved insert materials of similar characteristics or combination thereof having hard and strong and durable pieces and free from any adherent coatings. Number two, coarse aggregate should contain not more than 1 mass percent of material passing the 0.075 millimeters number of 200 sieves, nor than 0.25 mass percent of clay lumps and not more than 3.5 mass percent of soft fragments. If the coarse aggregate was subjected to 5 cycles of the sodium sulfate soundness test, the loss rate should not exceed 12 mass percent. If the slag is used, its density should not be less than 120 kilogram per cubic meter. The gradation of the coarse aggregate should conform to table 8 to 5. So water. Water to be used in concrete mixing or curing or other designated applications should be clean and free from oil, salt, acid, alkali, grass, or other substance injurious to be finished product. Drinking water, if used, needs to be tested. Reinforcing steel. The specification states that dual and tie bars to be used in concrete pavement shall confirm the requirements of ASHTO M31 or M42. Tie bars shall be deformed bars. Dual shall be plain, round bars delivered to the site with one half of each dual length painted with one coat of approved lead or the paint. The sleeves of dual shall be metal of approved design to cover 50 millimeters plus or minus 5 millimeters of the duals, with a closed end with suitable stop to hold the end of the sleeve at least 25 millimeters from the end of the dual. Sleeves shall be of such design that they do not collapse during constructions. Joint fillers. Joint fillers should be mixed asphalt and mixture or rubber filler. The preformed joint filler are punched to adherent. The duos filler for each joint should be furnished in a single place for the full depth and width of the joint. Number one is the provision for storage should be amplified enough to, and the shipments of the cement as received as separately stored in such a manner as to allow the earliest deliveries to be used first and provide easy access for identifications and inspection of each shipment. Number two is storage house must have its capacity to accommodate sufficient quantity of cement to allow sampling at least 12 days before the cement is used. Three is to secure uniformity of concrete mixture. The coarse aggregates are separated into two or more sizes. Proportioning consistency, and strength of concrete. Prepare a design mixture based on the absolute volume method as specified in American Concrete Institute or ACI standard. Number one is the intent of specification is to require approximately 9 bags of cement per cubic meter of concrete based on 40 kilogram weight per bag of cement. Number two is the engineer will determine from the library test for materials to be used and cement content and proportions of aggregates and water will be produced a workable concrete having slumps of between 40 and 70 millimeters if not vibrated, or between 10 to 40 millimeters if vibrated, and flexural strength of not less than 3.8 MPa when tested from third point method or 4.5 MPa when tested from the midpoint method or compressive strength of 24.1 MPa when tested at 14 days. Number three is the designer should be considered the use of lean concrete, which is econo concrete mixture using local materials for specifically modified conventional concrete mixture is base course and in the lower course of composite monolithic concrete pavements using a minimum of 75 millimeters of conventional concrete as the surface course. So quality control of concrete. For the quality control of concrete in general, the DPWH specification provides that the contractor shall be responsible for the quality control of all materials during the handling, blending, mixing, and placing operations. The contractor shall furnish the engineer a quality control plan detailing the production control procedures and the type of frequency of sampling and test to ensure the concrete produced complies with specifications. The supervising engineer shall be provided free access to recent plant productions records and if requested informationally copies of design, materials, certification and sampling and resting reports. Required qualifications of workmen. Concrete batchers. The person performing the batching or mixing operations capa- capable of accurately conducting aggregate surface moisture determinations and establish correct scale weight for concrete materials. Concrete technicians. The person responsible for concrete productions control, sampling, and testing for quality control, proficiency in concrete technologically, having a sound knowledge of the specifications as they relate to concrete productions. He shall be capable of conducting the tests of concrete and materials in according with the specifications. He should be capable of adjusting mix design for improving workability and specification compliance and preparing trial mix designs. He shall be qualified to act as the concrete batcher in the absence of the batcher. Equipment. The equipment and tools necessary for handling materials and performing all the phase of work shall be approved by a supervising engineer as to design, the capacity and the mechanical conditions. The equipment should be the job of site sufficiently ahead of start of construction operation to be examined thoroughly and approved by the engineers. So, batching plant equipment. The batching plan should include bins, weighing, hoppers, and scales for the fine aggregate, and for each size of concrete, the weighing hopper shall be properly sealed and vented to preclude dusting operations. So number two is the batching plan should be equipped with a suitable non-resealable batch counter which will correctly indicate the number of batches and proportions. And lastly, the bin and equipped separate compartment for the fine aggregates. And for each size of coarse aggregates should be provided in the batching plan. So number four is for weighing aggregates and cement should be of either the beam type or the springless dial type. This should be accurate within the half percent through the range of use. Postes should be designed to be locked in any position and to prevent unauthorized change. Scales shall be inspected and sealed as often as engineer may deem necessary to assure the continuous accuracy. The batch plan should be equipped with automatic weighing device of an approved type, proportions, aggregates, and bulk cement. Mixer. Concrete may be mixed in the construction sites or on central plant or wholly or in a part of truck mixture under the following conditions. So number one, each mixture shall be the manufacturer's plate attached in a prominent place, showing the capacity of the drum in terms of volume of mixed concrete and the speed of rotations of the mixing drum or blades. Number two is mixtures at the site of construction. Mixing should be done in a approved mixture capable of combining the aggregate cement and water into thoroughly mix and inform the mass within the specified mixing and distributing the mixture without segregations on the prepared grade. And number three is the mixture shall be equipped with approved timing devices, which will automatically lock the discharge level when the drum has the being charged and released at the end of the mixing period. In case of timing device failure, the mixture may be used for a balance of the day while it is placed repaired, provided that each batch is mixed in 90 seconds. So truck mixtures to be used for mixing holding concrete in a truck aggregators used for holding central mix concrete should be conform the requirements of ASHTO number of M57. Non-aggregator trucks, bodies of non-aggregating hauling equipment for concrete shall be smooth, mortar-tight metal containers capable of discharging the concrete of satisfactory controlled rate without segregations. So, paving and finishing equipment. The concrete should be placed and set with the approved paver designs to spread the consolidate, screen, and float finish the freshly placed concrete in one complete pass of the machine, in a manner that the minimum of hand finishing will be necessary to provide a dense and homogeneous pavement. The finished machine should be equipped with at least two speculating tape of transverse grade. Vibrator should be operated at 8,300 to 960 frequency in impulses per minute under load at maximum spacing of 60 centimeters. Concrete saw. Concrete saw should be cold diamond edge saw blade or abrasive wheel, confirming the required dimensions and rate of speed. So form. Form should be made of an approved steel section with a depth equal to the thickness of the pavement at the edge. The base of the form should be sufficient width to provide the necessary stability in all directions. So the fledged braces must extend outwards of the base not less than 2/3 of the height form. So all of the form should be rigidly supported on bed during the entire operations of placing and finishing the concrete. It should be provided with adequate devices to secure its settings so that when in a place they will withstand without visible spring or settlement the impact and vibration of consolidating and finishing of the concrete pavement. So preparation of grade. After the base or subgrade have been placed and compacted to the required density, the area that will support or the paving machine in the grade on which the pavement is to be constructed should be trimmed of the proper elevations by means of properly designed and machine extending the work at least 60 centimeters beyond each edge of the proposed concrete pavement. If the loss of density results from the trimming operations, it should be restored by additional compactions before the concrete is placed. If any traffic is allowed to use the prepared subgrade or the surface, it should recheck and corrected immediately ahead of the placing concrete. The subgrade or the base should be uniformly moist when the concrete is placed. Setting of forms. Base support. The foundation under the form should be hard and true to grade so that the form when the set will be firmly is contacted in the whole length and the specified grade. And number two is grading alignment. Form should be set sufficiently advanced from point where the concrete is being placed. So on conditioning the subgrade or base course, when the side form being securely set to grade, the base course should be brought to proper cross sections. Number two is unless the waterproof base course materials is specified, it should be uniformly moist when the concrete is placed.
Good morning, everyone. My name is Plantar Missy, and my topic is all about handling, measuring, and batching of materials. The batching plants and equivalent layout must provide smooth flow of continuous supply and transport of materials to the work. Stockpiles are built up in layers of not more than 1 meter in thickness, with each layer completely in place before beginning the next that should not be allowed to cone down over the next lower layer. Mixing concrete. All washed aggregates and aggregate produced or handled by hydraulic methods are stockpiled or bined for draining at least 12 hours before batched. The mixer should be charged without loss of cement, and batch materials should be weighed for each material required within tolerance of 1% for cement and 2% for aggregates. When mixing at a site or in a central mixing plant, the mixing time should not be less than 50 seconds nor more than 90 seconds, unless mixing performance tasks provide adequate mixing of the concrete in a shorter time periods. The batches shall be changed in the drum with the portions of mixing water ended in advance of the cement and aggregates. The flow of water should be uniform, that all water shall be inside the drum by the end of the first 15 seconds of the mixing period. Retempering concrete by adding water or by any other means shall not be permitted, except that when concrete is delivered in truck mixers, additional water may be added to the batch materials and additional mixing performance increasing the slump to meet the requirement if permitted by the engineer. Ready mixed concrete shall be mixed and delivered in accordance with AASHTOM-157 requirements. Specification for ready-mix concrete. Ready-mix concrete shall conform to the requirements of ASTM C-94. For each batch of concrete, it is the responsibility of the contractor to furnish to the engineer before unloading at the site a delivery ticket from the manufacturer on which is printed, stamped, or written information concerning said. Things to remember. The volume of the concrete should not exceed the mixer nominal capacity. Second, the accuracy of measuring water is not more than 1 error. Third, when cement is placed in contact with the aggregates, batches may be rejected. Limitation of mixing. No concrete should be mixed, placed, or finished when natural light is insufficient, unless an adequate and approved artificial lighting is operated. Things to remember in limitation of mixing. First, mixed concrete shall be transported in truck mixer. Second, the throat of the drum shall be kept free of concrete accumulation. Placing or depositing of concrete. Concrete is deposited in such a manner requiring minimal rehandling, unless truck mixers or non-agitating hauling equipment are equipped with a means of discharge concrete without segregations of the materials. The concrete should be unloaded inside the form in a manner to prevent segregation of the particles. Things to remember. First, placing the concrete between transverse joints without the use of intermediate bulkheads. If finishing equipment is carried on the existing lane, paving in adjoining lanes may be permitted only after 3 days. Vibrators should not be allowed to come in contact with the joint assembly. In no case, it will be operated longer than 15 seconds in any location. And last is, concrete should not be deposited as near as possible to the expansion and contraction joints without disturbing them. Concrete joints. Concrete joints are constructed according to the type, dimensions, and at the location as indicated on plans or special provisions. All joints should be protected from intrusions or injuries foreign materials until after seal. So there are 4 concrete pavement joints. First is longitudinal joints. Constructed when one lane of HMA is paved, then the adjacent lane is paved next to this, now called joints. Second, transverse expansion joints. Used when the paving operation is interrupted for longer than 30 minutes. These joints are commonly used at the end of the paving operation each day. Third is construction joints, a sewed form of tool groove in a concrete slab that creates a weakened vertical plane. So there are 3 types of construction joints. First is transverse strip construction joints. Second is formed groove. Third is sewed construction joints. And last is load transverse device, the term used in industrial flooring to describe the mechanism which allow the load imposed on the one side of the joints or cracks to be transferred to the adjacent side. Final consolidation and finishing. The sequence of operations after placing the concrete at grade is strike off or consolidation, floating and removal of lightens, straight edging, and final surface finishing. First, additional of water to the surface of concrete in order to assist in finishing operations should not be permitted. Second, the concrete placed adjacent to the joint shall be compacted and firmly set without voids or segregation under and around the load transfer devices, joint assembly units, and other features designed to extend into the pavement. Third, concrete adjacent to joints should be mechanically vibrated. Fourth, if the uninterrupted operations of finishing machine over beyond the joint causes segregations of concrete, the misalignment of the joints finishing machine should be stopped when the front screed is approximately 20 centimeters from the joints. Fifth, the front screed should be lifted and set directly on top of the joints, and the forward motions of the finishing machine is resumed. And last is thereafter, the finishing machine may be run over the joint without lifting the screeds, provided that there is no segregation concrete immediately between the joints and the screed or on top of the joints. Finishing machine, non-vibratory method. The concrete is distributed and spread as soon as placed. It is struck off, then screened by an approved finishing machine. Things to remember. Hand finishing. First, in the event of mechanical equipment breakdown hand, methods may be used to finish the concrete already deposited on the grade or form. Second, areas of irregular dimensions where operations of the mechanical equipment are impractical, hand methods may be used. Third, concrete as soon as placed is struck off and screed by an approved portable screeder. And last is consolidations should attained by the use of suitable vibrator or other approved equipment. Floating. After the concrete has been struck off and consolidated, it is further smoothened, trued, and consolidated by means of longitudinal float, either by hands or mechanical methods. Second, the hand-operated longitudinal float should not be less than 3.16 meters long and 15 centimeters wide. The movement ahead along the center line of the pavement should be in successive advances of not more than one-half length of the float. And last is the float should pass over each area of pavement at least 2 times. Straight edge testing and surface correction. After the floating works and excess water removed while the concrete is still in plastic conditions, the straight edge bar is held in contact with the surface in successive positions parallel to the road center line. Advances along the road should be in successive stages of not more than half length of the straight edge bar. The surface across the joints must strictly meet the requirement to smoothness. Final finish. If the surface texture is broom finished, it should be applied when water sheen has practically disappeared. The brooming operation is executed by producing uniform appearance of corrugation produced in the surface not more than 1.5 mm depth. Hand belt must have suitable handless to permit a controlled uniform manipulations. And last is for pavement 5 meters or more than in width, the drag is mounted on a bridge which travel on the form. Edging of forms and joints. All joints, transverse constructed joints, and emergency construction should be worked with approved tools and rounded to the radius required. All concrete on top of the joints, fillers should be removed completely. All joints are tested with a straight edge and corrected if one edge of the joint is higher than the other before the concrete completely set. Surface test. The pavement surface is tested with a 3 meters straight edge or other specified device, where the departure from correct cross-section exceeds 12 mm. And last is, any area that was removed should not be less than 1.5 meters length and not less than full width of the lane involved.
Good morning, I am Obros Fajardo, and I will continue the report of Miss De La Serna. So, curing. Immediately after the finishing operations and the concrete has sufficiently set, the entire surface of the newly placed concrete is cured in accordance with either one of the following method. So the first method is the use of cotton or burlap mats. Second is the use of waterproof paper. Third is screw curing. Fourth is by impervious membrane method. And lastly, by use of white polyethyl sheet. Cotton or burlap mats. A cotton or burlap mats can be used to wet cure concrete for the final curing process. These materials can wet cure by holding and supplying water. A wet mat is placed in the pavement surface and wait to remain in intimate contact with the pavement and maintain fully wet in its position for 72 hours, unless otherwise specified. The top and sides paper. The top and sides of the pavement is covered entirely with waterproof paper. The units are lapped at least 45 centimeters, placed and weighed down to remain in intimate contact with the surface cover. The cover should be maintained in place for 72 hours. The surface of the pavement is thoroughly wet prior to the placing of the paper. The third method is screw curing. When screw is used for curing, the mat is cured initially with burlaps or cotton mats until after the final set of concrete, or in any case, 12 hours after placing the concrete. As soon as the mat is removed, the sides of the pavement are thoroughly wet and covered with 20 centimeter straw or hay measured after saturation of water to last for 72 hours. So the fourth method is impervious membrane method. White pigmented curing compound is applied immediately after the finishing of the surface and before the setting of concrete has taken place. The curing compound is not applied during rainy days. Spraying equipment is equipped with a wind guard and the time and of use. Compound is thoroughly mixed with the pigment uniformly dispersed throughout the vehicle. So the last method that can be used is using the white polyethylene sheet. So the top surface and sides of the pavement is covered with white polyethylene sheet. The units are lapped to at least 45 centimeters, placing the sheet weight down to remain in contact with the surface cover. The covering should be maintained in place for 72 hours after the concrete has been placed. The next is removal of forms. Forms for concrete pavement should remain in place undisturbed within 24 hours after pouring. The removal could be done as follows. First, the crowbars are used in removing forms, pulling out nails and pins, but care should be exercised not to break the pavement edges. Second is a case portion of the concrete slab is peeled off. It should be repaired immediately with fresh mortar mixtures of 1:2. Major honeycomb area will be considered as defective works to be removed and replaced. Protection of pavement. Concrete pavement and its importance should be protected against public traffic and traffic caused by the workers. Protection of the pavement includes the posting of watchmen to direct traffic and posting and maintaining of warning signs, lights, pavement bridges or crossover, and etc. Next is concrete by the slip form method. If the contract calls for the construction of concrete pavement without using a fixed form, the following shall apply. First is the grade. After the grade or base have been placed and compacted to the required density, the areas to support the paving machine is cut to proper elevation by means of properly designed machine. The base where the pavement is to be constructed is brought up to proper profile. Placing of concrete. Concrete is deposited inside form using an approved slip form paver, designed to spread, consolidate, screed, and float finish the freshly placed concrete in one complete pass of the machine, in such a manner that minimum hand finish is obtained yet provide a dense and homogeneous pavement in conformity with the specification. Acceptance of concrete. The strength level of concrete will be considered satisfactory if the average of all sets of 3 consecutive strength tests results into equal or exceed the specified strength, and no individual strength test result is deficient by more than 15% of the specified. The last process is the tolerance and pavement thickness. Thickness of the pavement will be determined by measuring the core from the completed pavement in accordance with ASH 2 T148 requirements. Pavement thickness. It is the intent of these specifications to set pavement into a uniform thickness as planned for the average of each lot as designed. So first, in calculating the average thickness of the pavement, individual measurement in excess of the specified thickness by more than 5 mm and the measurement less than the specified thickness by more than 25 mm should not be included in the average thickness. Second is when the average thickness of the lot is deficient, the contract unit price will be adjusted. Third is individual area within the segment found to be deficient in thickness by more than 25 mm will be evaluated by the supervising engineer. And last, when the measurement of any core is less than the specified thickness by more than 25 mm, the actual thickness of pavement in the area will be determined by taking additional cores at no less than 5 meters. Adjustment for thickness. So when the average thickness of a pavement per lot is deficient, payment for the lot will be adjusted as follows. In our table, we have in the left side is the deficiency in the average thickness per lot mm, and the right side is the percent of contract price lot. So every 0 to 5 mm, we have a 100% payment, and to 6 to 10 mm is the 95%, 11 to 15 is 85%, 16 to 20 is 70%, 21 to 25 is 50%, and more than 25 is remove and replace. Methods of measurement. The area to be paid under this item is the area in square meter of the concrete pavement placed and accepted in the completed pavement. The length is measured horizontally along the center line of each roadway or ramp. Curb and gutter will be included in the area of concrete pavement measurement. And lastly, opening to traffic. The project engineer will decide when the pavement may be open to traffic. The road will not be open to traffic until after test specimens molded and cured in accordance with ASH 2 T23 have attained the minimum strength requirements. If such tests are not conducted prior to the specified age of the concrete, the pavement will not be open to traffic until after 14 days from the time concrete was placed. Before opening to traffic, the pavement should be cleaned and joints completely sealed. And that's the end of the report of Group 8. Thank you for listening.